Welcome to Khetz Tutorials, and in this video, I'll be doing questions 6 and 7. The questions say, the graph of y equals square root of 3x minus x squared is given. Use transformations to create a function whose graph is as shown. So to figure out what the equation or what the function should be, we're going to use this original and we're going to figure out what happened to it to get each of these. So let's start with 6. Alright, so this here has a space of, it's from 0 to 3, that's a space of 3. Let's look at here, from 2 to 5, that's also a space of 3. So that has not been tampered with. But let's look at the peak. This peak is at 1.5 and this peak is at 3. So that has actually been stretched by 2 to have that peak. Then to move from a starting point of 0 to a starting point of 2, it has been shifted to the right by 2. So these are the transformations which happened from the original to 6. You can start with any of them. So one of them is that it was shifted to the right by 2. Even the 3 was shifted to the right by 2. As you can see, the stopping point is at 3 and it's now at 5, so that it shifts to the right by 2. Also, it was stretched by a factor of 2. So if this is our original, this is how we're going to apply what we have. We're going to, if this was f of x, so let's say that this was f of x, then to apply the transformation, to shift by 2, we'd have this. Then to stretch by 2, we'd have this on top of that. And this is exactly what we're going to do. So you're going to have a right shift by 2, and we're going to have some stretching by 2. So this is the final function. This is what we're aiming for. And this is how it would work in this function. So you multiply everything by 2. Then wherever you see an x, you'd substitute x minus 2. That's how transformations work. And at this point, you can just multiply through. So let's see what we get. We're going to have y equals 2. And in here, we can multiply through over here, which is 3x minus 6, then minus, then this will be x squared minus 4x plus 4. And we can add everything inside. You're going to have negative x squared. You're going to have a positive 4 minus minus. Then that would add to the 3 over there. So that would be 7. Then we're going to have minus 6 on the outside minus the 4 on the inside. That will give us minus 10. Alright. So this is the final function which we're going to have that represents the diagram which is shown under 6 or at 6. So we have stretched it by 2 and we've shifted it to the right by 2 units as well. And this would be the final function that you're going to have. Moving on to 7. Now let's figure out what happened for us to get 7. So obviously it was flipped around, or it was reflected about the x-axis. So if you reflect that about the x-axis, then it will look like this. But as you can see, this is not exactly below the original, so it was shifted to the left. So it was at 0 and it's now at minus 4. So there was a shift of 4 units to the left, and that's why it finds itself somewhere there, which is 7. Also, it's no longer touching the x-axis, which means it went down. Let's see, it was at a y of 0, but it now went down to a y of minus 1 as the starting point, which means it went down by 1 unit. So now let's document all of those things which happened to it. 7, there was a reflection about x. Then there was a shift by 4, so we went to the left by 4. Then finally we went down by 1 unit. And once again, if our original was f of x, here's how you'd apply all of these things. The reflection would be minus, so let's write them down progressively as we go down. So this would have been minus f of x. We negate the y when we reflect about x. Then we went left by 4, so it would have now been minus f of x plus 4. That's what we would have had. Then finally, we went down by 1. So everything, or the y, will be affected by removing 1 from it so that we go down. So this will be the final function that we're aiming for, and that's exactly what we're going to do in the original. So this is our original function, and in here we're going to apply all of this. So firstly, we're going to negate everything. Then wherever we see an x, we're going to substitute x plus 4. Then finally, we're going to subtract 1 from everything again. So this is what we're going to do. You just have to multiply through to answer the question. So we have a negative on the outside. And in here, we have 3x plus 12 minus x squared plus 8x plus 16. Then all of that minus 1. So the minus 1 is not in there. It's after all of that has been done. Then we can continue. You're going to have negative x squared, then minus 8x in there, added to that 3x. So 3x minus 8x will give you minus 5x. Then we have a 12 minus 16. So that will give you minus 4. And finally, we have that minus 1 on the outside. So this is a function which now represents or describes the diagram that you see at 7. And we use the original to find that. So it's very important to understand the translations or what happened to the original to get to this point, because that then guides you to figure out your substitutions and how you should actually change the function to match what you have or what you can see.